Hello, everyone, and welcome to today's webinar. On behalf of American Petroleum Professionals of Iranian Heritage, APPIH, it's our great honor to start another webinar entitled Contemplating the End of the Fossil Fuels by Mr. Rick McCordy. Rick is the Vice President of Innovation and Sustainability for Select Energy Services, a US-based service provider active in the water sourcing, treatment, reuse, and the chemical application spaces. In this role, Rick is focused on minimizing freshwater use and evaluating technologies that may lead to beneficial use of the treated produced water in the future. As such, he's an active participant in the produced water consortiums underway in the New Mexico, Texas, and Colorado. Prior to Select, Rick served as a senior engineering advisor for Chesapeake Energy, where he was a primary developer of Chesapeake's initiative championing the use of produced water in oil and gas operations, AquaRenew, and the industry-leading Green Frac program that focus on environmentally friendly hydraulic fracturing additives. Rick served as a technical expert during the US EPA study of the potential impacts of hydraulic fracturing on water reuses and has presented to the National Academy of the Sciences, Engineering, and Medicine, the Government Accountability Office, the Department of Energy, and the Energy Information Agency regarding water use in energy sector. Rick has an AS degree in petroleum technology. I would thank Mr. McCordy for accepting our invitation, and without further delay, I'm transferring microphone to him for starting his presentation. Thank you.
All right, and thank you, Hamid. I appreciate the introduction, and I would like to start off by saying that this presentation is long overdue. Hamid saw me make a condensed version of this 6-7 months ago and asked if I'd be willing to present to this group, and I said I would, and unfortunately life and work gets in the way sometimes, and it took us 7 months to get to the point to where we could make this happen. But I'm here tonight and very honored to be speaking to your group, and particularly about this subject called Contemplating the End of Fossil Fuels. And let me start off by saying, while I work for Select Energy Services, which will soon, they're currently under a rebrand, they'll soon be Select Water Solutions, this presentation in no means reflects the position of Select Energy or Select Water Solutions. This presentation is of my own volition and reflects a lot of my opinions, though you're not going to see a lot of opinions in here at this presentation. What you're going to see is a lot of information and a lot of historical presentation of data that's available out there regarding climate change and the energy transition process. But I do want to clarify that my company, this is not something that they're promoting. This is just something that I champion periodically. So having said that, let's look at our agenda for this evening. I'd like to start out by talking about just how close we are to the end of the fossil fuel industry, which I think I'm been in the fossil fuel industry for just shy of 43 years now. So, and I know many of you or all of you do that, and we're concerned about exactly where that end is. And a particular concern is attracting young people into the petroleum industry when the concern is perhaps that it's not going to be around very much longer. And after we kind of talk about some of that, I'm going to talk about some trust issues I have and trust issues with how this subject is being discussed globally. And then we're going to move on to a topic called catastrophizing and defining it and giving some examples of what that particularly is. Then we're going to look at some of the models out there, and I'm going to talk about some of the issues that I have with those models. And then lastly, we're going to talk about some failed predictions and histories of such, and then circle back around to our agenda topics here and wrap the discussion up. So I originally started looking at this topic back several years ago for another presentation and covering a couple of slides on it, and I'd kind of forgotten about it, hadn't really thought about it till last summer. And in June of last year, I was watching a webinar that was being hosted by the Intermountain West organization, or what's commonly referred to as iWest. And it was a webinar, three-hour webinar, focused on the introduction to water and energy transition in the Intermountain West area. And some of you may be aware, but for those that are not, the Intermountain West is a group composed of two of the national labs, Los Alamos National Laboratory and the National Energy Technology Laboratory, as well as several universities that are in the Rocky Mountain area as well as the Western U.S. Now, for this webinar, they also partnered with Sandia National Labs in New Mexico to host a number of talks. And the talks were focused on green energy and transitioning to green energy, as well as water demands of that transition. Now, as such, and particularly as for many years it's been a topic, but it's really boiled to the surface over the last couple of years, is this focus on something is very near and dear to my heart, is can some volume of beneficial water be recovered out of produced water in the U.S. in order to help with water resiliency, particularly in these drought-prone areas such as West Texas and New Mexico, Arizona. And as such, roughly a third to maybe 40% of the talks during this webinar were on the possibility of recovering some volume of fresh water from produced water in these areas, particularly if that water could be used in conjunction with production of a green energy source such as hydrogen. That's another big topic right now. And the two primary methods of making hydrogen these days are blue hydrogen, which is steam reforming of natural gas, or green hydrogen, which is using an electrolysis process to separate the hydrogen and oxygen molecules in water. Either way, both of those methods have a huge water demand. So there were a lot of talks on, could this be a potential source of water for producing a green energy source? Now, what really grabbed me as I was listening to the various talks was during one of the question and answer sessions, is a young PhD asked the question, if we're no longer going to have oil and gas in the next 2 to 3 years, why are we even talking about produced water as a source? And it stopped me. And I said, well, I understood her. I heard that right. And it wasn't in jest. She was earnest in her question, and it was obvious that she believed that we would no longer have oil and gas in the next 2 to 3 years. And I went back and revisited some of the other research that I did on this a few years back, and then started expanding it a little bit. And that's what's going to evolve into the presentation that you're going to see today. So let's start out with a period of about 3.5 years ago from Washington, D.C. And hopefully many of y'all will remember the Green New Deal. The Green New Deal was a non-binding resolution put before Congress, and it was introduced by Congresswoman Ocasio-Cortez and Senator Markey, both out of the state of New York. It was intended to address the need to drastically reduce greenhouse gas emissions within the next 12 years. Shortly after the Green New Deal came out, there was a professor out of the University of Colorado Boulder, Dr. Roger Pielke Jr., who regularly writes on energy and economics. And he put a paper together addressing this need to get to net zero, to move to a carbon neutral world. But he felt like in his paper that it was an impossible task to do this within 12 years, as it was addressed in the Green New Deal. And so he decided to set a more realistic goal. This was in 2019, the fall of 2019, and he thought, what would it take to get to net zero carbon dioxide emissions by the year 2050? Which was essentially 31 years away. So he started doing research, and he looked at the available global energy demand information from fossil fuels for the year 2018, which was the year prior to him writing this paper, and determined that the energy demand from fossil fuels during that period was 11,743 million tons of oil equivalent, which is just one of the common units of measure we use for measuring huge amounts of energy, right? And for reference, 1 million tons of oil equivalent is equivalent to 11,643 gigawatt hours worth of energy consumption. So he also took a look that at the time he was writing the article in October of 2019, there were just so happened to be 11,051 days between then and the year 2050. So taking a look at anticipated global energy demand increases over that time period, he determined that in order to meet this goal of being net zero by 2050, we would have to replace 1.6 million tons of oil equivalent of fossil fuel energy with renewable energy every single day until the year 2050. And as you'll note at the bottom of this slide, and many of the slides all of the slides I will be using tonight, wherever I'm presenting statistical information or information that I've pulled from somewhere else, I try to cite it the best I can so that you'll always be able to go look at the source of the information. So if we know we've got to replace 1.6 million tons of oil equivalent every single day from that period on, what will that require? Well, it just so happens in this article, Professor Pilkey gave a few examples. One was the Turkey Point nuclear reactor in Homestead, Florida. He picked this nuclear reactor complex because it was active and because it just happened to have an annual power generation output of 1 million tons of oil equivalent energy. So based on the need for replacement, we would need 3 of these new Turkey Point nuclear facilities every 2 days until the year 2050. We're 3.5 years away from Dr. Pilkey's paper, so we're currently roughly 1,900 nuclear power plants behind schedule. And there's a reason for that. One is we're not big fans of nuclear anymore. Having said that, I'm a big fan of nuclear. I think it's a good deal. But if you're old enough, then the picture I posted at the bottom of the slide here is of the Chernobyl nuclear power facility in the former Soviet Union, which obviously had a nuclear reactor meltdown and is now just kind of a barren wasteland in that area. If you're a little bit younger and don't remember Chernobyl, you probably remember the Fukushima nuclear reactor disaster in Japan, when a seismicity-induced tsunami swamped this facility and once again caused a major reaction and major meltdown within the nuclear facility. Based on these 2 incidents, primarily in a history of opposition to nuclear by the environmental movement, particularly in the U.S., is basically on a no nuclear standpoint. We just can't allow nuclear. So if we're not going to allow nuclear, what are we going to do? Well, let's look at nice, clean wind turbines. That's how we're going to supply renewable energy. The one we happen to be looking at here, and I took that photo, by the way, is a 2.5 megawatt turbine, and this turbine has the capacity to generate 7.6 gigawatt hours per year, will generate 7.6 gigawatt per year at the current 34.6 capacity average. Keep in mind with a wind turbine, the wind doesn't always blow, and it doesn't necessarily, it can blow too little or it can blow too much, and you can't get the work out of the wind turbines that you need. The wind conditions in a lot of geographical areas aren't conducive to putting a wind turbine there. But if we're going to look at wind turbines, to meet that 1.6 million tons of oil equivalent replacement goal we have every single day, we'll need 1,500 wind turbines per day until the year 2050. Again, we're 3.5 years away from this paper, so we're currently roughly 1.9 million turbines behind our schedule for 2050. Now, you may be saying, some of you might be saying, well, wait a minute, the world is deploying turbines and solar farms, Rick. Are those being included in these estimates or these numbers? And no, they're not. So I think that's a fair question. Let's take a look at that. How are we progressing? So between the year of 2020 and 2021, the world added 256.7 gigawatts of renewable energy capacity. As we just discussed, energy is a function of both capacity and efficiency. The current calculated efficiencies, we just discussed wind turbines at 34.6% of their rated capacity. Solar is not quite as good. Solar panels will give us about 25.7% of their rated capacity because the sun doesn't shine 24 hours a day. And sometimes it's very cloudy, or sometimes we have snow on top of the solar panels. So it's not always ideal that we're going to get that capacity out of them. Hydroelectric tends to be more efficient. Hydroelectric functions much like a coal plant, so you generally get the capacity of the plant that it was designed for. So based on that added capacity and working into the calculated efficiencies, the world added 94.1 gigawatts of usable renewable capacity between 2020 and 2021, or 824,000 gigawatt hours of energy. That 824,000 gigawatt hours converts to 70.9 million tons of oil equivalent, or 12% of the goal needed each year for net zero by 2050. Now, a rough rule of thumb here would tell us that if we are meeting 12% of our goal to meet net zero in 30 years, it's going to take 8 times that amount of time to actually hit that goal, or 240 years. So when I did that calculation, I thought, well, okay, does that seem accurate? Well, let's take a look at a couple other pieces of information. This information here comes from the Solar Energy Information Agency. Their goal over the next 10 years is to add an additional 500 gigawatts of solar in the U.S. Based on the current costs that we have for the amount of solar energy that we have currently deployed in the U.S., that's going to require an additional $123 billion worth of investment at current cost to get to that 500 gigawatts of solar capacity. Now, that capacity equates to 12.85 gigawatts of available solar power being added each year, or 0.08% of global fossil fuel energy demand. So once again, we're not really setting the world on fire when it comes to replacing these fossil fuel energies. Another way of looking at this is if we take a look at the BP Statistical Review of World Energy. In 2021, the globe added 603 terawatt hours of renewable energy, the largest ever single year growth. Now, incidentally, I went back and looked at 2021 and 2020. In 2021, even though it was the all-time greatest addition of renewable energy, it was only 4.3% greater than 2020. So we're not seeing an exponential increase in these numbers. We're just seeing an increase, even though each one is the greatest year ever. Now, in 2021, the world consumed 136,000 terawatt hours of fossil fuel energy, which incidentally was 4.6% greater than what the world consumed in 2020. So while renewables are increasing, fossil fuel consumption is increasing at a slightly higher rate for this period than renewables were. So if we take a look at the 2021 edition, which was the largest ever renewable addition rate, and we said, well, not knowing what we're going to increase going forward, just maintaining that rate, it will take 226 years to completely replace fossil fuels. If we could completely replace fossil fuels, there are certain things that fossil fuels do now that renewables not going to do, nor is 3D printing going to solve. So taking a look at that, I took a look at a few other estimates out there and predictions going forward. Here is one that incidentally this shows in 2020, renewables accounted globally for about 19% of the average per person energy consumption. Looking forward to the year 2100, that number was expected to increase to 24%. So while we would see an increase in renewables over that 70-year period, or in this case, 80-year period, it wasn't that large of an increase, nor is it coming anywhere near replacing fossil fuels. In fact, in this example here, you see that fossil fuels actually increased by a much greater amount during that period, or not so much a percentage, but the overall fossil fuel consumption increases greatly during that period. Taking a look at one more estimated example using a model. This takes a look from the International Energy Agency, and it takes a look at global renewable contribution. Obviously, if you go back here to the year 1800, renewables accounted for about 95%, 95% of the energy. Why? Because it was predominantly peat moss, wood, things of that nature. This was before oil had come along. So, and then as oil come onto the market and we saw fossil fuels pick up and we saw more of that come on the market, we saw the amount of renewable energy fall off. Then we come down here and we get into more of the present day and we see some modeling. But even the models as they go along, here was the International Energy Association's model from back in 2010, which basically said by 2030, 2040, renewables would be at 20%. What we actually see is they're down here somewhere closer to about 12%, 13, 14% maybe. And if we take a look at all the different models, with this one outlier up here, which puts us at roughly about 44% renewables, all the rest of the models are somewhere between, say, 12 and 25% renewables. So, and that's by the year 2100. So we're still quite a ways away from replacing fossil fuels. And replacement's not the full story. We hear a lot about replacements and the need to replace and everything that we need to do. You know, I talked about not having fossil fuels. Shortly after watching that webinar, I was on an airplane, and one row behind me and across the aisle, I heard two individuals talking, and the comment was, we have to get rid of fossil fuels in the next few years or we're doomed. And I just kind of turned around and glanced at them. And then I glanced at the airplane that we were sliding through the sky at 520 miles an hour. And I thought, okay. But now, if we're going to replace all this fossil fuel energy network and infrastructure to protect our communities and the global environment, we're going to have to decommission this infrastructure as we replace 1.6 million tons of oil equivalent every single day. And what's that going to require? Well, 1.6 million tons of oil equivalents equal to 10.7 million barrels of oil coming off the market every single day. Or if we're looking at natural gas, that means we're going to shut in or replace 61.6 billion cubic feet of natural gas every day. Every single day. That means we're going to have to decommission refineries and safely restore them to where they're not an environmental hazard. We're going to have to decommission natural gas plants and do the same thing. We're going to have to take care of our offshore platforms and decommission those by the same process. And lastly, we're going to have to take a look at coal-fired power plants and decommission those as well. So it's not just the cost of adding the renewable energy that we're looking at, it's the cost of having to decommission all this fossil fuel infrastructure that I don't think is being baked into the equations properly. So that's kind of, obviously from those comments, you can see that I don't believe that we're very near the end of fossil fuels. I think they're going to be around for quite a while. And now we're going to talk about some of the reasons why I feel like perhaps the public has a misunderstanding of exactly what is at stake here and what's going on. So first of all, let's talk about some trust issues that I have. Many of y'all may remember this originally popped up 2009, 2010, and it was referred to at that time as Climate Gate. It later became referred to as Climate Gate 1.0 as there was a second deal that came out a few years later. But in 2009, 1,000 plus emails and 2,000 other documents were hacked from the Climate Research Unit at East Anglica University in the United Kingdom. And the researchers at East Anglica were heavily involved in the Intergovernmental Panel on Climate Change. These emails included discussions on how to have the Intergovernmental Panel include only the views of scientists who supported the global climate change narrative and exclude scientists who had different views on climate science. For example, Phil Jones, who was director of this climate center at Anglica, in an email to Michael Mann at Penn State University, said, and I quote, "We will keep them out even if we have to redefine what a peer-reviewed paper is." And in a reaction to these hacked emails and documents coming out, one of the people who was negatively portrayed in a lot of those emails was a climate scientist at Cato Institute who had a contrarian opinion about climate change, Pat Michaels. And he was quoted as saying, "This is what everyone feared. Over the years, it has become increasingly difficult for anyone who does not view global warming as an end-of-the-world issue to publish papers. This isn't questionable practice. This is unethical." As I said, a couple of years later, a second trove of emails were hacked. And in these emails, we saw where some of the people involved in the earlier ones were working on ways to not have this repeated and have this doubt and information be put out to the public about some of the inner workings of what was going on with these climate change scientists. Phil Jones, who I mentioned earlier, in an email released in the second batch, was quoted as saying, "I've been told that the IPCC is above National Freedom of Information Act request. One way to cover yourself and all those working in AR5 would be to delete all emails at the end of the project." Other emails reveal admissions of the scientific shortcomings of global warming assertions. Observations do not show rising temperatures throughout the tropical troposphere unless you accept one single study and discount a wealth of others. This is downright dangerous. We need to communicate the uncertainty and be honest. And this was from Peter Thorne, who at the time was with the United Kingdom Meteorological Office, in an email to Phil Jones. This information coming out, and there was a lot of rebuttal and try to cover on a lot of it and all that, but I find it concerning. When we set a narrative and then we try to completely squash all dissent, that is not how we as scientists operate. That is how totalitarian governments operate. They said this is the governmental tone, and if you dissent from it, we will punish you. And that's not how we should operate as scientists. So now that we've talked, that's what gives me trust issues, let's talk about catastrophizing. So what is catastrophizing? Well, if we look at a definition from Psychology Today, it is a cognitive distortion that prompts people to jump to the worst possible conclusion, usually with very limited information or objective reason to despair. When a situation is upsetting, but not necessarily catastrophic, they still feel like they are in the midst of a crisis. So I'm going to go through some examples of catastrophizing that have happened over the last several years and take a look at some of the information that doesn't support the catastrophizing. And I know I'm going to screw up saying that word. Well, for years now, we've heard that sea level is on the rise. And it is a drastic sea level rise, and it's going to cause much damage throughout the world. Matter of fact, in 1988, there was a prediction that the Maldives nation of islands would be completely underwater in 30 years. Now, for those that may not be familiar with the Maldives, this is a chain of roughly 1,000 small little sea islands southwest of Sri Lanka. And they are, as you'll see in this photo here from Google Earth Pro, the reason they're color-coded as blue is because Google Earth color codes everything according to like a topographical profile above sea level, and they're barely above sea level. The land base itself is just mere meters above sea level, thus why the prediction was made that sea levels would rise and they would all get flooded out. However, this is a current satellite photo of one of the main inhabited Maldive islands, and there's the Valanya International Airport, which seems to be doing quite well 35 years later after the initial prediction was made that these islands were going to be underwater. And again, here is a track of global sea level rise over the last 30 plus years, and it is on the rise. And we see during this period of it is averaged 3.3 millimeters per year. So over the last 30 years, we're looking at 96.7 millimeters of average global sea level rise, which is about 4 inches. So not saying it's not of concern, but I believe that is something that can be addressed by people that live on the coast and how best to adapt to that level of sea level rise. Another claim that we hear nowadays that with global warming, weather-related disasters will increase. Yet when we look at the data of global weather and climate disasters over the last 22 years, we see a downward trend in the number of disasters that have been documented around the world. Another claim, climate-related deaths will increase. We hear that quite often these days, yet once again, when we take a look at the data over the last 100 plus years, global climate-related deaths have decreased drastically. And of course, this is because we have developed technology. We have technology that warns us in advance of large-scale phenomenon. You know, the worst ever recorded deaths from a hurricane in the U.S., I believe, was in 1905 from a storm that hit Galveston, Texas. And in those days, they had no advance warning other than barometric pressures dropping drastically as the hurricane started to move on shore. But that wasn't enough for people, particularly in 1905. They didn't have the means to get up and move quickly out of the way. Nowadays, people do. They have the ability to move. We have the ability to construct structures that are more resilient to climate-related disasters. Another claim, hurricanes will increase in number and intensity. Yet, when we look at the data, again, this is over the last 50 years, and we see the dark bars there indicate Category 1 and 2 hurricanes. The gray bars indicate Category 3 plus. I don't think we see a discernible trend or increase in either one of those over this 50-year period. Droughts are going to be more frequent. Yet again, when we review the data over the last 120 plus years, we see that the amount of land that is deemed to be in drought conditions globally has slowly decreased over that period. So that's kind of some examples of catastrophizing. We're making statements that are very alarming that do not have data to fully support those statements. But now we need to take a look at some of the models that are being used nowadays to drive us toward this desire that we have to move away from fossil fuels. And if we don't, it's going to be very bad. And in hand with that, the Intergovernmental Panel on Climate Change just announced a few days ago their most latest report. And in their most latest report, they said this was our last dire warning, that if things weren't done immediately or quickly, then there would be no turning back from all of these things that we have just discussed. So let's take a look at the data or the models and some of the issues that I have concerns with about the models. Now, this was a comment that came out of one of the articles that says the Earth is barreling toward hothouse state, not seen in 50 million years. Now, what is that claim based on? Well, that claim, if you take a look at this chart here, this chart is average global surface temperature based on ice cores uh, over the last 65 million years. And we go back 50 million years ago, and we were in what is referred to as a hothouse period, when it was significantly warmer across the globe than it is now. Then we see us coming down through these periods where we come down and we hit the ice age here, come back up out of it, come into here. This would have been our little ice age period sometime around in here. And then we see a slowly kind of warming coming out of that little ice age period. And then we get to the present day and we see where models kick in that tell us what they believe the average surface temperature is going to be moving forward. And if we take a look, the model that they're using for this statement here is this RCP 8.5, which says that by the year 2300, we're going to be back up here in these extreme hothouse conditions. And that's fine. That is a model. But then we look at the other models down here that say we could actually see little or no change or a slight decrease, and other models that fall somewhere in between. But of course, we picked this one to make this statement. But how accurate are models very often? Well, here is a model or a prediction that was put out by a gentleman who at the time was the director of the Goddard Space Institute. And he made this in 1988, and he, based on this warming trend here, said that he gave two different predictions. And he said, looking forward into the year 2018, which is that time was a 30-year look ahead, that the global temperature would be somewhere between 3 and 5.5 degrees Fahrenheit greater than what it was. Yet, if we look at the NASA observations of temperature over that period, while we do see a warming increase, it is significantly less than what he predicted. When we take a look at some of the different models that have been done, taking a look at various different degrees in global temperature, we see a funny trend here. We see them somewhat kind of tracking with actual observed data. We see one down here in gray that actually one out of these does a fairly good job of tracking observed data. But then somewhere here about 1995, 1966, they start diverging, and all the models start drifting drastically higher. While at the same standpoint, if we look at tropospherical temperature readings taken from both balloons and satellites, we see that the actual observed temperatures is far lower than what the models are predicting. Yet the thing about that I guess irritates me to some degree about models is we never seem to go back to try to understand why is a model deviating from what we are seeing as known results, and why are we not correcting the model to where it more accurately predicts what we're actually seeing with our actual measurements. So lastly, we're going to touch on failed predictions. And there's several articles out there. You can go search for them, and you'll run across them periodically that talk about many predictions that have been made about the global climate and weather. And obviously those are two disconnected things over the years. And I'm not going to run into all of them, but I'm going to touch base on some of the ones that are more popular. One of them we had is I ran across this just the other day, and is there any need to even talk about this? Are we too late already? This was a tweet put out by a young climate activist who many are probably aware of, Miss Greta Thunberg. And she retweeted an article by another climate scientist that basically said, a top climate scientist is warning that climate change will wipe out all of humanity unless we stop using fossil fuels over the next 5 years. Note that this tweet was originally put out in 2018. Well, we're 5 years later now, and we have not stopped using fossil fuels. As a matter of fact, it's increased quite a bit over what it was 5 years ago, and yet we're all still here. Now, it should be noted that Ms. Thunberg deleted this tweet from her profile, but as so many people are finding nowadays, nothing ever really goes away. Another conservative activist had saved this tweet and reposted it, asking Ms. Thunberg why she had deleted the original tweet. So I was able to grab it there. So looking at some of the failed predictions, well, one of them would be the coming ice age. And I am old enough to remember when a lot of this was being circulated around. And here were some of the comments at the time that were being made. Article in the Washington Post, 1971. U.S. scientist sees new ice age coming. From The Guardian in 1974, space satellites show new ice age coming fast. In 1974, from Time magazine, another ice age. And in that article, it was quoted, telltale signs are everywhere. From the unexpected persistence and thickness of pack ice in the waters around Iceland to the southward migration of warmth-loving creature like the armadillo from the Midwest. The New York Times Book Review looked at a book in 1976 from Stephen Schneider, who was a climatologist at the National Center for Atmospheric Research, and the book was called The Cooling. And The Cooling talked about the cooling trend and the movement toward the new ice age. 1978, New York Times, no end in sight to a 30-year cooling trend. And yet, here's the data over the last, once again, 40 years. And in 1978 would have been right here. And no end in sight to the 30-year cooling trend, and yet ever since then, all we've seen is a warming trend. As a matter of fact, by July of 2019, the average temperature had increased 0.38 degrees centigrade from that measured in 1979. Acid rain. Not sure how many of y'all remember that, but I do remember from my youth or as a young man that was a huge concern. Article in the Noblesville Ledger from 1980, acid rain kills life in lakes. And this was a big concern. There was major concerns over what acid rain was going to do to aircraft, to aluminum skins of aircraft if they flew through this acid rain. Would it cause deterioration of the airframe much faster than expressed? And yet 10 years later, the government had done a study and they said acid rain is not an environmental crisis, study concludes. Arctic ice. We have a lot of these. James Hansen, who I'd mentioned earlier, was at one point the director of the Goddard Space Institute, and we're going to come back around and talk some more about him a little bit later. In 2008, he said the Arctic will be ice-free by 2018. Al Gore, former vice president and presidential candidate in the U.S., in 2008, he also said the North Polar ice cap will be completely ice-free in 5 years. In The Guardian in 2013 was an article, Ice-Free Arctic in 2 years heralds methane catastrophe scientist. Again in the article, same year, again in The Guardian, same year, another article, U.S. Navy predicts summer ice-free Arctic by 2016. Yet, when we go look at the data and we look at the area of the ocean for Arctic sea ice extent during the winter months in the Arctic, we see that the average extent million square mile or kilometers of ice is right in line with what it has always been, or at least for the most recent future. Obviously not going back to the ice age. So I mentioned James Hansen. Let's talk. I'm not picking on him. It's just that he's got a history of making predictions that don't come true, and yet he is still considered in high esteem within the movement when it comes to climate science. Again, I mentioned he was director of the Goddard Space Center for many years. In 1980, I showed you this graph a while ago. He predicted a 0.28 to 0.56 Celsius increase in global temperatures over the next, essentially, this was 88 actually, over the next 30 years to 2018. In reality, what was seen, I'm getting confused with my deal. So in 80, he predicted this. In reality, what was seen was an increase of 12 degrees, 12 degrees C by I believe it was roughly 10 years, which was off by a factor of 2 to 4. For the 2000s, he predicted a change of 1 to 2 degrees Celsius, whereas reality, we saw a 1.9 degrees Celsius increase, which means he was off by a factor of 5 to 10. This was in the Miami News in 1988. More droughts likely. Expert tells senators. This was an interview with James Hansen with NASA. And once again, if you've ever heard of the term greenhouse effect, Hansen was the one that invented that terminology and was thus predicting that the Earth was warming. This was his forecast date here. This is the upper Midwest climate region, precipitation May through April. Obviously, from the time he made this, they've seen nothing but an increase in precipitation rate in the upper Midwest during that period. So droughts did not increase in that area. Same year, also 1988, excuse me. Mr. Hansen said, prepare for long, hot summers. If you like last summer's record temperatures, you're going to love the 1990s. He also said that Washington, D.C. would go from its current 35 days a year over 90 degrees to 85 days a year over 90 degrees. And the level of the ocean will rise anywhere from 1 to 6 feet, which we've talked about sea level rise previously. This is the number of days above 90 degrees measured in Lincoln, Virginia, near Washington, D.C. This was Hansen's prediction date here. And as we've seen, we saw nothing but a downward trend in those days above 90 degrees since the time he made that prediction. So that's going to wrap us up. We've talked about how close we are to the end of the fossil fuel industry, and hopefully you come away with this presentation with the understanding that it's not going to be any time soon. I'm not saying it will not eventually happen. Everything changes with time. But I think for most of us in the industry, we don't have to worry about learning how to install a wind turbine or clean solar panels quite yet. And hopefully the word that we can share with the youth out there that are interested in joining the petroleum profession is it's likely going to be around for quite a while, because it's not going to be easy to move away from it. We've talked about trust issues and what drives me to be pragmatic and take a look at this and not just accept things on a face value. We've talked about catastrophizing, and unfortunately, the worst part about catastrophes, there are people that do get affected by that. There are people out there that I believe are genuinely concerned and scared because of what people are telling them about the climate, and they're not taking the time to go look at data and try to balance and reason out the two. The models, I mentioned this, and that's something that I find somewhat infuriating, is that the models always seem to be off, and yet we never seem to go back and correct the models, which that ought to be something that's simple to do. We do that all the time with some of the stuff we work with. If we're missing the mark, we go back and adjust the formula or adjust the equation to where it corrects the data. And so I'm not sure why we do not see that happen with this climate modeling. And lastly, failed predictions. Now, in all fairness, if you've ever heard the phrase "a broken watch is right twice a day," you can make a lot of predictions and eventually you're going to be right. But then again, that means you've also made a lot of predictions that are wrong, and that should be taken into consideration as well. And so that's going to be the end of our talk. I appreciate everybody's time that you're going to devote to taking a look at this, and feel free. I'll put my contact information up here. Once again, obviously this presentation is me. This has nothing to do with the company that I work for. I'm not promoting any of their services or anything like that, but I'm always happy to have a discussion around this and a discussion around my passion for the industry and the passion for the people that work in it. So thank you for your time.
Thank you so much. You had a great presentation. I really enjoy. I think you need to write a book about all this subject. I encourage the audience, if they like, they can unmute themselves and ask the question, or if they like, they can write it in the chat or Q&A. I will take care of the question. In the meantime, I have some questions that I can ask. Is there any things that you are worried about the future? It looks as in your presentation, future, there is no problem in the future.
I do not have the concerns that when and honestly the IPCC just came out with CC two C's just came out with their most latest report just a few days ago, and it was dire. It was twofold. Number one, it was dire that this is our last warning that we're giving you that something has to be done now. And to be honest with you, I don't believe that's going to be the last warning, but that's what they said. But then they went, but here's good news. If you will do this right now, we can avert this disaster. I believe more in the ability for our industry and other industries to transition to a resilience mode. If first of all, I do not doubt the fact that our planet is warming. Climate constantly changes. We looked at that 65 million year graph, and obviously you saw a change in temperatures during that period. So what I do have concerns with and doubts that we can do anything to effectively slow that change. And at what cost? It literally, to get to where they really want us to be to maintain this 1.5 degrees C is literally going to cost the gross domestic product of the whole globe to make that happen. And I don't think people understand what that means as a cost to the individual around the world. I'm also concerned we have somewhere in the neighborhood of I believe it's 2 billion people that are still living below the poverty line and who are still cooking off of wood fires and animal dung fires. And how great it would be for those people if they had abundant fossil fuels available to them, to where they could improve their lifestyle and get above the poverty period, and what that would mean. And it's hard enough to believe that we're going to transition the modern world without having to we're not going to skip that and immediately go to that part of the country and go, okay, we're going to put in solar farms and wind power and stuff for you as well. I also get concerned that we talk a lot about the availability of wind and solar without talking enough about the fact that that energy is transitional. It's not supplied. You know, a coal-fired power plant or a natural gas power plant will sit there and generate that energy source 24 hours a day, and wind and solar will not. And if they can't, then what do we do when they're not supplying that power?
Do you believe that CO2 or CO2 related compounds like methane or nitrogen oxide cause any problem for environment and cause any, let's say, temperature increase or not?
So, you know, it's funny that we all know that plants love CO2. That's how they respire, right? They take in CO2, it goes through photosynthesis, and they in turn displace oxygen back out into the atmosphere. The more CO2 that a plant has to consume, the more it's going to grow. Mm-hmm. There have been several studies out there that have shown that if they take a little tree in a greenhouse setting and they take several identical shoots of a tree and they say, this one we're going to water and maintain at ambient levels of CO2. And this one we're going to put in a tent and we're going to pipe in a little extra CO2. And this one we're going to do the same, but we're going to add an additional amount, and this one an additional amount. And after a 6, 8 month, 9 month period, you can see significant difference in all the growth heights. And it's all consistent with the more CO2 is available, the faster the plant grew and the larger it grew. So obviously plant life is going to increase as CO2 increases. We still, again, we go back to, we keep hearing this, that the global ice sheets are going to melt. This is going to lead to mass extinctions and this increasing temperature is going to lead to mass extinctions of various forms of wildlife. I have not seen the data that supports that. I can't see. I'm not going to argue that we may see some additional weather-related incidents from global warming. My personal belief now, and I'm not trying to be contrary, but when somebody goes, look, it's on the news all the time, Rick, you can see there are more events now than there used to be. That's because we have much greater coverage now than we used to. 30, 40 years ago, you were lucky if you knew that something happened to somebody in rural Illinois, if you didn't live in rural Illinois. Now you know because it's on the news for 5, 10, 15 seconds on a loop. And so you get to see it. So we get to be more prevalent of that. That not saying it's the same thing, but it's very similar to, you go, look at the seismicity. Look how much more seismic events were happening. I'm not denying we're not having seismicity, but part of the reason we see more events is because we're putting more monitoring stations out in the field. That doesn't mean some of them weren't there before, we just had no way of monitoring it.
My last question, as you have significant experience in the water, how do you see the future of the water in the world with the two different aspects, the water that we consume for many industrial purposes, plus when we use the fossil fuels, almost molar equivalent, we produce water as well. That water most probably is not accessible in some sort. How do you see the future of the water?
So, to be perfectly honest with you, in my belief, and I mentioned this kind of starting off, I'm very passionate about the possibility that we're going to be able to reclaim some volume of beneficially used water out of produced water. I think we're right on the cusp of doing that now. I think the economics are getting to the point to where a lot of companies would consider using that sort of technology if it was available. We're working industry is working very much hand in hand with states and the federal government that's taking a look at that to come up with regulations that would allow that to happen. One of the things that I was talking about this earlier today is a lot of times when we talk about this, people go, well, there's no way I'm going to drink that water. Well, that would probably be the very last thing that would ever be considered. But as you mentioned, Amit, there are so many other industrial uses of fresh water that could be displaced with a treated produced water. And anytime you displace a liter of that water, of fresh water, that gets to be used by somebody for drinking. Most of the states out there that routinely go through drought, not saying drought's increasing, drought has been a function of many of the Western states for their entire history. And for them to be able to conserve that fresh water, because most of them have 50-year water look-ahead plans that they update routinely, and most of them, like Texas and New Mexico, will tell you now, and Colorado will say, we're not going to have the fresh water we need for our population 50 years from now. So how do we conserve that fresh water the best we can? We do that. We take a look at all available resources, whether it be brackish water, some other industrial wastewater, or produced water, and we see, is there a way to efficiently and safely recover fresh water out of that? And I believe there is.
Excellent. You have an amazing experience and knowledge, and I really, really enjoy. And I hope one day you can publish a book containing all this funding that you have, and very, very, very useful.
Well,
Would be
I,
very
I,
useful.
I want to say once again that I really do appreciate the invite to speak to this group. Sorry it took so long to make it happen.
No, no, thank you so much. Okay, let's finishing. Once again, I would love to thank you, Mr. McCordy, for accepting our invitation and such an interesting presentation. And thank you for everybody for taking part in this event. I really appreciate it. Have a nice evening.
All right. Thank you very much and see you soon.
See you. Bye.